Ladies and gentlemen, good day. Hello. Welcome to Dr. Plurings Lithium Battery Experimentations Laboratorium. Last time around here second to last time around. No, last time around we assembled the battery. The time before that we did some theoretical theorizations upon how to charge this thing and how it could work and how it may not work and so on. Today it has come time to put a little bit of that to practice, that theory. So it's time to actually start charging my battery. I have here the app, the BMS app, so you should hopefully be able to see more or less what's going on with it. We currently have where is it? The average cell voltage difference is 11 millivolts as it stands right now. When I've not charged them at all, I've discharged them a bit since they arrived here. But there you go, and it claims to have 64% remaining in the battery. It doesn't know. Apparently, maybe I've drawn 3 amp hours out of it since the BMS was connected to it, but I'm not trusting that because the runtime here, where is it? There, it says that it's been running for 5 hours. It's been running for more than that, so I don't know when that resets and so on. But here we go. To charge this, I have an old PC power supply out of an HP. Something rubbish, some rubbish crap, really. Completely, properly rubbish crap. Home PC thing, I think it was. I got this out of, but it has then, it has 2 12-volt rails, right? Yes, one for 12 amp and one for 16 amp. And so that should be plenty. And for testing this out and actually doing the charging, I have 3 of these here constant current, constant voltage boost converters. So I turn that on, does that make a difference? Not really. That, a little bit maybe. So that's fine. What I intend to use, these 3, we could go over just a quick and short repetition of the theory that was laying out here previously. So make sure that my power supply for my camera is on, for my phone is on. That's the bad battery. That one isn't all that, you know, all that. So here's the deal. Should we check first that the battery is working? And then we have something coming out of it. This over here with the black wire is the positive rail, sure, and this would be the negative rail. 26 volts and 26.2, and the battery management BMS claims 26.3, so they are still not quite in agreement, but somewhat close enough, I say, at least for whatever it is you're supposed to try to do here. Yeah, sure, mate. A little bit of a schematic then of just what it is that I want to do. We have the battery, the plus and minus, and those are here, plus and minus. I've joined these together here, so all of these they have like 4 connection points for each and every one of them. So positive rail there, negative rail there, and we want to be feeding this what is it now, 3.65 if we want to load charge this all the way up, and I sort of want to do, but it's going to take forever. But yeah, times 8. So that gives us then a total battery voltage of what? A total battery voltage of 3.65 times 8, 29.2 volts. This should mean that the battery is fully charged. So you see, we won't be able to get to that today, because it's going to take hours and hours. Yeah, we'll see just how much power we'll be able to actually put into it. But the idea here then is to have these here boost converters and the power supply, which has a 12, just down here, 12 volt, and hooked that up to a boost converter, one of which is set for 3.65 volts. So yeah, this is also for not maybe the most optimal way to charge the battery, but it's also for testing my hypothesis here, if it's actually going to work in the caravan or not. So, and another boost converter at say 3.65, that too maybe. So we do two at full cell voltage and a third one at 3.4, and simply do this. For the moment, the ground is abstracted. There we go. So yeah, this is what I intend to try and do now with this there, and with the power supply there as the power supply, 12 volt. It has yellow cables, and it also has this the CPU power thing. So I suppose that is one of these is the second rail, and one is the other. I don't know which one is which. It doesn't matter. We won't get up to those currents, or will we? You know, it works out like so. Yeah, this you might already know how this works. I'm just going to go through it in my head here. I'm thinking out loud. Is what I'm doing here, and testing it and so on. So, if what should be set as a reasonable charge current for each boost converter? I don't disremember here now with the specifications. Let me double check this. I think that they were rated in Chinese sense, that as a maximum of 15 amperes, and that will of course be on the low side then. Because if it is 15 amperes here, and it's going to be stepped up to 29.2. So if you want 5 volt, that's a factor of what? A factor of something. First, let me check just the rating of these here things. 15 amp step-up boost converter. What do you say about specifications? Not lot there. There. Input current 15 amp maximum. If more than 8 amps, module temperature more than 65 degrees, please strengthen heat dissipation fan. But so 15 amps might be maybe pushing it a bit. Maybe we'll go try and start at least with 8 here. Amperes. What will we then get on the other side? assuming that these are 100% efficient, which they aren't, but for simplicity's sake, and being able to make this calculation, I'm assuming that they are 100% efficient. So we want to go from 12 volts up to 29.2. Oh, right. Sure. That should be a factor of 2.433333. 29.2. Oops, I touched something on the BMS. 29.2 divided by 12 is 2.4333, and so on. 8 amps there. If we can do that safely, say 8 divided by 2.433333 would give us then the enormous amount, the enormous current here of 3.2 amperes per boost converter. That's maybe at least a safe-ish place to start at. I'm thinking and hoping anyway that it will be. Let's see how I'm framed here. I think I'm reasonably framed. It's as good as you're going to get. In any case, this is a daytime video. I'm having coffee. Good stuff. There you go. Okay, and this power supply thing, I'm just going to hack into it because I really don't care about it at all. More or less, not even more, simply less. I simply do not care about it. This is from a PC which I will probably not use. And for one rare occasion, HP actually has built a computer with a completely standard power supply in it. Maybe that isn't so rare. Maybe it's just that I'm so very rarely deal with HP consumer products. I can tell you, in servers and workstations, they like to do lots of proprietary things, as do Dell as well, and everyone. I can't really say that HP is any worse or any better than Dell. Okay, into this here ATX connector, we have two yellow wires, right? And then we also have yellow coming out to the SATA power connector step, but we only have 2 in here. Yep, that's what you're going to get. There, mate. And if we're going to pull 8 amps, these are a bit thin. But no, it is quite a short distance. I think that we'll use both to feed into the boost converter. And Dr. Pluring, he always knows where he has his tools. Actually, in the toolbox this time. I didn't know it. So there and there. That should be the first one. Yes, twisting them together, not putting a ring terminal or anything on this. Which of these are in and out? This is the inside, input side. They're a bit long, I think, to fit comfortably in there. Cut them. Rather. There we go. And the positive is that one. Maybe undo this first here. these terminals aren't all that great neither. So if this relay is rated for 15 amperes, it is fused with one 15 ampere fuse, so I don't suppose that there's a whole lot of headroom to those 15 amperes, because that fuse there is going to blow pretty much. And well, yeah, 15 amperes, I was supposed to get the wire into here that can supply 15 amperes. Don't know. Problem for later. Problem for later. And ground. I've already taken the power on pin out of this connector and bridged that to ground, so that should be all right, all good. Try and bend these rather than cutting them. Maybe this time see if we can get a bit more confidence inspiring connection into this. Nah, they won't go in that way at all. Okay, these terminals are slightly undersized, maybe for 15 amperes. Yes. There you go. Okay, now I might have taken off a bit too much of the wire instead. There you go. We shall see how it goes. I think it might be alright. There you go. See if I can read this correctly. This potentiometer here should be the current adjustment, and the other one should be the voltage. So I can find a screwdriver. Screwdriver with the blue handle on it, which usually is pretty good for doing these types of potentiometers. I don't know. It should be around here somewhere. There it is, at the very bottom of the toolbox. Made it good. Yes. Excellent. Oh, what was it now? Constant current. If you turn that down, well, you can't really turn this without also agitating the capacitor. Unless you have a tiny screwdriver. I'm agitating the components in all sorts of ways here. Yeah. So, can I find a smaller one? I doubt it. Very much doubt that I have a smaller screwdriver readily available, at the very least. I definitely own one. I most definitely own a smaller screwdriver, but where is it? Where would you have that? Yeah, that's the question indeed. If I'm going to do a bit of adjusting here on this power supplies, then or voltage regulating converters, whatever you prefer to call them, could be worthwhile finding the correct screwdriver, or a more correct screwdriver for the job. Sure, mate, but it doesn't seem like it's your sense of order isn't really conducive to finding things when you need them. Yeah, I noticed. What's this then? This might contain something. tiny Phillips head, slightly less tiny Phillips head. No, these are tiny hex thing. Tiny Phillips. No, nothing there anyway. That's a shame.
Should be hiding something more down here, maybe in the toolbox.
This one is very useful, isn't it? That goes in the trash. Well, you were hiding something from us here. This one. This one will do. Now we should be able to adjust it without agitating the components around too much, hopefully. And since the components are pretty loose here, and these things are going into a vehicular application, I think it might be prudent to sort of cover this thing with some sort of epoxy or something. To just simply hold the components in place better. Can't help but feel that I've turned this so many times now that I should feel it click. That's meaning that you have now turned it to all the way there as far as it will go. Well, I might have turned it all the way up too, because it is which is up and which is down. Let's see here if we try. They all seem to be it has to be counterclockwise to turn it down. Simply has to. I don't think it simply has to. You should not make assumptions. Oh, you should make measurements. That's what we should do. Your probes are not going to quite go in there. I might have different probes. Let me check. It's not going to help. Are these going to help? Not a lot. Oh, never mind. I'm going to have to do this the old-fashioned way, I suppose. Let's do something in here. Nah, not really. Oh. Keep things in order. Put that back there. There we go. Okay, I think we can actually power this on now and see what happens if this thing blows up immediately. I really should have bought the safety goggles. Nothing seems to be happening so far. There's no... Well, maybe it doesn't have an LED on it, this one. So you can somewhat safely measure the output here without shorting it. I think so. I'm uncertain. It will be very difficult to hold this in here. Whilst also, there you are, 11.9 volts. How is that even possible? What's the output? Like, that should not be possible. Should it be possible for a boost converter to output a lower voltage than what is put into it, right? 12.1, 12.2. Maybe I've actually succeeded in turning both the current and voltage down to absolutely nothing. See, we can maybe if we hold the positive probe there, and I'm assuming that it is common negative through this thing, isn't it? Yes, so we can do that maybe. Yes. Now we turn the current up a tiny bit so that the voltage can actually do something. For the moment it seems like there is actually lower voltage coming out of this than going into it, which is almost a feat in itself. Okay, I'm adjusting, nothing's happening. Oh, nothing's happening. Let's see if we turn the current up a bit too. There we go. You need a bit of current apparently. There, 19.2. Exactly. There. And it is actually the other way around. The voltage one, turning it clockwise, turns the voltage down. And the current, I don't know quite yet. Okay, well, 19.2. This is my worst multimeter. Really should not be using this one. It's the one I trust the least out of all of them. And I don't know. I'm not sure about the current that if I have it set to like maximum or if I have it set to nothing. But it ought to be set to very low, since I have to turn it clockwise in order for the voltage to work or show sensible numbers at all, right? I'm thinking. But according to you, we have 0 volts. Really? Is that right? Is that so? 19.1. Okay, so the other meter may be a little bit on the low side. Okay, we have a third meter. 19. You want 29. Right. Just the 0.2. That got me thinking there that I already had it right. It's not right at all. New voltage DC. 19.10. Okay. Yes, here we go. Come on, carefully. Wow. Yeah, what could possibly go wrong? Maybe I should get some safety goggles. I don't want electrolyte squirted in my eyes. Yeah. But there you go. 23, 20. Zero volts, yes, because you moved off the terminal. 25.6. Yes, nothing bad is ever going to happen if I do that. Nothing. But the probes are catching on each other here and therefore preventing each other from actually making good contact. Ah! Careful. Please. Careful. Yeah, but I can't actually see the slot where this is supposed to go. There you go. 29.2. Three. Okay. Doesn't seem to want to. 29.2 exactly according to this thing. Now what do you think? my trusty old meter that I got in school, that I had for 25 years or so. So most of my measurements that I've ever done has been off or on 29.2. So they are all referenced to this in either case, right? And also the Biltema thing here. So what you say about the things. 29.4. You're obviously the one that is incorrect, and this one I don't trust it at all, because if you measure resistance with it, it says that the internal leads of it have like 9 ohms resistance, which they well might do, but then the leads to it are pretty rubbish. And if you measure current, it measures like at least twice as much current as there actually is. So that's not a good product at all. There you have it. Now see here if we can actually connect this then. Yeah. We start by doing the positive. Sure, we can start by doing the positive if that's what you feel like. I won't really have a quick disconnect for any of this though. That's how it is. But we can always do the old trusty method of just doing like that initially to the thing. We have the potential rather easily here to go above the current limit for this thing. Quite easily. We might blow the thing immediately, but yes, I think since I had to turn that down, I turned it down before powering things on, the current limiter, and then I had to turn it a few turns to get the voltage to do anything. It ought to be set to something that is pretty low, at least. It ought to. It must be. We're hoping it is as such. Now this is not dangerous. Nothing is going to happen right now. This won't be a complete circuit. Screwdriver for this. There we go. And negative. I want to go with a solid one here as well. Ah, sure. That's what I had. And also the solid ones. It seems that the terminals here, the maximum that they can accept is a 1.5 square millimeter solid core wire. So this ought to be the best way of it. But this is on the low current side. It's on the other side that you really would like the most possible current carrying capacity. Yes, and right about now is when I'm going to then try and actually connect my charging thing here to my battery. There you go. 0. Here, eye protection. Yeah, it is indeed set to a very low current, if anything. I'm not sure it makes a difference if I connect this or not, actually. No, because you haven't, the charger isn't on. But the voltage might, maybe should do something, no? Right, we have to, here, control, charge, allow charging. There you go. Okay. Yeah, that is a reasonable current to start with, 1.2 amperes. I can screw this in. Okay, my battery is charging for the first time ever. I'm charging my battery. Lovely. Not with a whole lot. No, a total of 0.9 amps according to the BMS and 1.15 according to this thing. 25 watts we're putting into it then. Yeah, the math sort of works out on that. Okay, is this getting hot? Not quite yet. Constant current adjustment. If we can turn this up a little bit. What was the limit again that we wanted to keep? I might not actually have written that. Yeah, it's 3.2. To be in the very safe half of what the Chinese claim that it can do. So that should be about 2, approaching 2 amperes. Yes, 2 amperes, 50 watts. Okay. Yes, all is well. Knock on wood. 3.2. That's where we're at now. Let's see how hot this gets at this level. You're getting 100 watts into the battery, you say. 3.5 amps there, according to BMS, and 3 amps according to my meter. Okay. I'm actually trusting the meter a bit more than the BMS, because the BMS apparently needs to be calibrated, and to do a proper calibration, or to get as good as a calibration as possible, they claim in the manual that you should have it under high current when doing it, and we're not going to get very high current. 15 amps is the maximum we're going to get. Okay, this is starting to not get hot, but it's starting to get slightly warmish. Anyway, it's not even warm, but it's definitely doing something. So if we're putting 100 watts in, 92 watts in, we're not, but it's something thereabouts, and it doesn't get any hotter than this, then it's pretty damn efficient at this level anyway. Try increasing the current a bit more maybe. What should we be able to do if for 15 amperes on the 12 volt side? So 12 divided by 29.2, that is 0.41. Pen. Hopeless person. Your pens and your screwdrivers and everything. Oh, this is really easy stood. It's right there. 12 divided by 29.2 equals 0.41. And what was the reason for me wanting that number? I'm not sure, but we could check just for fun. We could see here 3.2 amps now. If we take times 2.43, which was the factor here in the voltage difference factor, we should be at about 7.7 amps on the other side of the boost converter. Are we? Pretty close, 7.8. It's starting to heat up, but it's not warm. The coil is a little bit warm. We can bring the fan in, blow on it. There you go. Should maybe have the meter on this side of things, since that's where things might happen, and things might get exciting and so on. Right, and we adjust the current up a little more. Yes, I'm trying to find the slot here on the potentiometer. I'm using the correct screwdriver, yes I am. It is very difficult here. There we go. 8 amps on the input, 8.8 and a half, 8.6, 8.9, 9.5, 10 amperes. Should we set it for that maybe? The Valium power supply was again, what was it that you were comfortable doing? 12 on one rail and 16 on the other one, and I don't know which one's which. Maybe we should keep it around here for now. At least the PC power supply there, even if it came out of a completely rubbish computer, I'm sort of trusting that to both provide a stable voltage and also protect itself from overcurrent situations and such, so it's not going to blow up. Hopefully, they still do sometimes, but I'm at least trusting it to be reasonably designed not to blow up. Okay, the cloud here is hindering airflow over it a little bit, I think. There we go. There, right. I'm charging my battery. 5 amps, and you say that the remaining capacity is 103 amp hours. If we just assume that this has any clue of what's going on right now, just for argument's sake, then we are 57 ampere hours short, right? So if we were to do that at a rate of 4.4, or maybe closer to 4 actually, and it will take 14 hours. Okay, not that bad. 14 hours to charge this setup. Yes, you are heating up, but I'm not worried. There. For the time being, at the very least. That should be good. And the fan like so. That does anything for you. And get another one hooked up here and see if my theory actually holds true or not. That reminds me, before actually doing anything else, I'm going to connect something in between the power supply and the wall. One of these here things, so you get some sort of idea of the amount of power we're putting into the battery from a somewhat trusted source, but not accounting, of course, for inefficiencies in this thing, which is already getting a little bit warm. But still, it will be something. Let's go to check here in the Home Assistant if it is showing up there and if it's doing anything. Hello. Fine, I'll check it on the phone. If I can find this thing in here. It should be settings, I think, and then use devices and services, and Zigbee home automation stuff. A little plug number 1. Yeah, 155 watts. Apparently. 155 watts, and of that 120 or so actually goes into the battery. I suppose that's about what you could expect efficiency wise from one of those. and these and what have you. Yeah. I need to clear my nose a bit. Be right back. Let me know if it blows up there. There we go. How hot are you getting hot? No, not really. It's cooling. We're not getting hot. Yes, we have 10 amps on the input. It's rated for a maximum of 15, but I don't think I'm comfortable going above this ever on this. This seems to be a reasonable spot for them to hang around in. Let's say, how are we doing with the framing? Oh, not too terrible. And which, if I were a power supply maker, would I say that my 12A rail is the yellow one that goes to the motherboard and goes to the various to hard drives and stuff, or would I say that yes, and thereby saying that the 12B rail is the one that goes to the CPU, or would I think the other way around? I don't know. If I were a power supply maker, I'd write that on the label here, which one's which. That's what I do. But they didn't. It is charging. Still number one for some reason is there's quite a decently lower voltage. Well, it is lower. It is lower than all the other cells. Anyway, might have a bad connection to the BMS lead. Might be many things. Okay, let's see. This wire is not getting hot. No, they're not. Good. So should we do two? If I want to use 3 of these here, buck converters or boost converters, maybe we'll be satisfied with only 2 of them. It would be enough to prove or disprove my hypothesis theory I'm testing out here now. If we can use 2 of these at set to different voltages at all, whether that's going to work, if that's going to work. According to some people on the internet, this is not going to work at all. This one that is set to lower voltage is going to provide absolutely nothing. According to some people on the internet, yeah, but that wasn't the thing. The things I read about these types of devices and using them is when they're used as power supplies. And when you're not really current limiting in such a way that we are here. Here we are current limiting and we're charging a battery. We're driving a load in that sense. Of course, charging the battery is still a load. Yes, but the load, the voltage of the load will rise, so to speak, whilst these are doing their thing here, which is a bit different, right? And we're doing current limiting, so that's why I'm thinking that maybe this could work. A little bit more of the wire sticking out there than I'd prefer to have. current, turn that down all the way. Maybe it is already turned on all the way since this was brand new, but I don't know. Usually these potentiometers have a little click in them when you're at the end of the range. I am not so sure that these do, or at least that I can feel. And the voltage regulation was the other way around for some reason. So to turn that down, I'm turning it this way. Yeah, that doesn't feel counterintuitive whatsoever. Oh. I might have actually gotten a few more with me there than I wanted to. Do that again. Today I'm not speaking rubbish on all sorts of things. I'm actually sticking to this and I'm being quiet in between. Do you prefer that? Is anyone watching? What the hell is that? Oh, that's the meter, the ampere meter that is reminding me that I didn't turn it off. The frequency at which it what the hell was that? Why would you do that? Charging up your capacitors, maybe. Yes, but then you should only do that for a bit and then they should be charged up. Now they are. What? This is sparking when I connect this. I'm not liking the fact that it is sparking. At least, I mean, the first time around it will be alright to charge its capacitors up, I suppose, but then on subsequent touchings there, why should it still be sparking? I don't know. Shut up! Maybe it self-discharges very quickly or something. Here, who knows what's going on. This one is capacitor here on the input is like really wonky. Okay. As I've been through before here with buying stuff off AliExpress, the thing is that the product might be excellent from the beginning, or it might be rubbish, complete rubbish from all the way from the start. But it may well be that you're actually buying stuff that didn't pass the quality inspection, maybe, for example, for some reason or other. Since you're most likely not buying from the manufacturer or someone who even has a relationship with the manufacturer. The thing I'm going to do here is I'm going to turn the power off and hook this up properly, because this I'm not liking the sparks, and I have shortened this slightly too much to get a good connection, and the positive one, which is already connected, is poking out a little bit. I'm definitely trusting the short circuit protection in the power supply though, so that should be fine, but still unnecessary. There you go, now we should be getting the sparks here. No. And I did not have the polarity reversed. No, at least not if the circuit board is printed correctly and everything, but everything is a bit wonky. Yeah, so what you might be buying off AliExpress there, it might well be stuff that didn't pass the quality testing of the manufacturer, and rather than throwing it in the bin, they go sell it to the lowest bid or the highest bid from their perspective. And you, before it ends up in your hands, it can have gone through a few of those. You never know how it goes, you know. See, I suppose that you will not want to be sitting. You want it to be sitting in there. Well, that makes things a whole lot more comfortable for me. 12.9. Fourteen. See if we adjust the current up a little bit, if that does anything. No, it doesn't do anything at all. Adjust it down all the way. It should eventually reach a point where the voltage drops, but it is clicking now, the potentiometer for the current. So is it already at maximum? The only way to find out is to turn it like 99 turns or 300 turns or whatever it takes the other way. And maybe the voltage will still stay here, since I don't have a load on it. It would appear that we're not going to get any more clever out of that anyway. Oh, and for every turn I'm making, that little capacitor is moving about. See, where was the bottom? There you go, that's the bottom. We'll just adjust it up a little bit to about there. And now let's set the voltage. And we did have 3.65 times 29.2 is what we had. So say that this one we're going to charge at 3.4 volts. Per cell. So 3.4 times 8, 27.2. Twenty-seven point four to 27.8 to 187.8. Okay, 27.2. There you go. Okay, just going to check this with the other meter as well. The one that was beeping here just a moment ago when I turned itself off now. No, I still needed you, so I didn't turn you off. There and there. And what do you say? What? I had it set for amp metering. Does that collect this in series, you think? By a shunt maybe? It might. No volts. No. Not AC. But DC. 27.2. Great. Oh, wire. Oh. And I already wasted all my longer ones there apparently. Okay, well then I suppose we'll move you over to there. Are you getting hot or anything? No, it's warm. It's what it is. That should be fine. This isn't solid. Here, this is multiple thing. Flerkardelig kabel is what we have here. FK. Connect that since there is a yellow and green. I suppose we're going to use this for a ground, for negative rather than ground. Negative. To keep to some sort of sense. Well, that was possible, completely possible to get in there. I think this one has bigger terminals on it or something. And the other one had. There, and connect it there. What? Why would that happen? The power supply shut off. Oh, what the fuck was that? Why would it do that? That was negative. This is negative. These touched maybe, but that should be negative touching negative. I think I blew my power supply up. Any funny smells? Either the power supply or the plug, well, it seems to be working. Yeah, but that definitely blew the power supply up. Okay. Why would that happen? I don't know, mate. I don't know, mate, why that would happen. But it did. I assumed that brown out here was the second positive rail. It has to be the second 12-volt rail. Yes, and I went to negative. No, what? Huh? What's going on? What the hell just happened? Turn the plug on. No, what's? Oh, I blew the power supply. For some reason. Oh, why did it do that then? It's pretty warm. Yes, but it should not. It did not overheat. It did not overheat at the same exact instant that I touched that to there. That is not what happened. But what the hell? What the hell was that about? It's a good thing I took the absolute worst power supply I had to do this test. I don't understand this, pretty simply. And I don't think that was a fuse or anything that actually blew. I think that was something else that blew in here. Now, these are not entirely safe since they're still connected to the battery. Should we maybe make that a non-circuit before continuing here? Yeah, we did charge it a little bit. Yes, a few ampere hours we got into it maybe. Not by a lot. Okay, yeah, sure mate, I'm not, I don't know what happened. Let's just get this out of here. There you go, I don't, now it's not a circuit anymore in any case. What happened? I need to think a little bit now. And why would that happen? My reckoning is that as far as the power supply is concerned, these are just two loads. They do go through here, but it was when I connected the negative that something blew. And why would that be? These were also in contact, but it really shouldn't matter, because that should be the same. They should already be the same. The negative here and negative there should already be the same. They are the same, guaranteed almost. Yes, they are the same. Are these the same, the positive ones? Yeah, the positive ones are the same too. More or less anyway. 2 ohms of resistance in between them. But yeah, that seems to be about what the leads here have. Okay. What the hell happened? And why? Is this one not good? Yes, but I only connected the negative of it. That is what is confusing me slightly. And these are, if I measure the continuity across this thing, negative to negative, those are already the same thing. So, well, maybe if by connecting that up there, I provided a second return path for the current to go back in there, and I did provide a second return path, and maybe these are using the return current somehow to regulate something or other, and that maybe, because I don't feel as okay, my sense of smell isn't the greatest at the moment, but I should still I'll be able to smell like a burnt silicone or electrolyte, and it did sound a little bit like it was a fuse almost that blew. So if by connecting those two together, I provided a second return path for the current, and that then in turn made this do interesting things, such as doing overcurrent, putting things in an overcurrent state. I pulling more than 12 amps through here, maybe. Speculating here, but I would prefer to be able to explain what just happened, especially before going and connecting another power supply up to this. But if that's the case, then you should probably connect the positive first, because there can be a dead short between the positives as well. So that's probably what you should do. In that case, I've learned something. See what sort of screwdriver do we need to open this up? Regular Phillips. No Torx, isn't it? It's funny because to get this out of the case, which it was in, I needed a Torx driver. That was a rubbish. Fit very well. But to open this up where you can actually access deadly voltages, you just need a Phillips screwdriver. Okay, sure. This is by no means safe to open this, even though it is unplugged. Of course, since it has capacitors in it, and they might still be charged. Such it is. Such is it, rather. But then this whole thing falls apart basically if I can't connect two of these in series. Okay, you come off about like so, and do we have more screws? No, not there anyway. And you come off like so. Excellent. There's a cable tie there holding the whole thing on to wires. And this, I mean, come on, HP. Are you HP or are you Alibaba Express here? Look at this, there is nothing protecting the wires going through the hole. They don't have any protection sock on them or anything. This is indeed a cheap product. It came out of a cheap product. This is even cheaper, I'd imagine. See if there is a fuse or something in here. Come on, thank you. Is there a fuse? Not obvious. Not an obvious one anyway. There's a potentiometer, which may well have been voltage regulation for it. There seem to be shunts, but I do not see a fuse. The underside. No. Neither do I see anything that is obviously burnt or has like smoke burn marks around it or anything like that. Will that be inside there? What's inside there? What's inside this heat shrink thing? I might be overshot, I'm sorry. I'm doing silly things. But there aren't that many capacitors in here. That one is the beefiest one, there is only one. This was quite a rubbish power supply, obviously, since it blew up. And I might have had something to do with it blowing up. I obviously had something to do with it blowing up, but I really would prefer if I could explain what just happened. You think you're safe to touch this? I mean, we could run a screwdriver or something under the. For example, here there is a capacitor. Yes, this is completely now it is secured. We'll definitely touch all the capacitors now, shorted them all out. Oh yes. Most certainly so. That's the big one. Where is it? It's there about. I think it is going to be as should only hold on to it with one hand if I'm unsure about this. Yes. Would you hide the fuse in here? If you did have a fuse. No, this is just some. That's pretty hot. No, but this is some sort of. No, that's only high voltage stuff, and some sort of magnet thing that it goes through for interference suppression purposes, I'd imagine. I almost made it through the heat shrink, so I'll try and continue eating away at it. Oh. There you go. Yeah, indeed, that was only one of those. Only one of those. Yeah, ferrite core things with the AC looping through. No, I really don't see a fuse. What's that? Was something hot? Or there might be a fusible resistor somewhere which I can't see. There might be. No, you never know. Well, there's nothing obviously wrong with this that I can see. Usually when these things go boom, it's pretty damned obvious what's happened. There's a big black thing around whatever went wrong or whatever component failed. But I'm not seeing it. And I'm not seeing a fuse neither. That goes onto the board there, and what's this thing that has heat shrink on it? It's either a resistor. No, that is a fuse. That you can see it, but the outline of it is very much indicating to me, at least, that that is a fuse. What's the point of having a fuse if you make it completely impossible to replace? Well, the point is still to prevent disasters from happening. Yes, but yeah, this power supply was built to the absolutely lowest price point ever possible, I would think here. How much does it really cost to add a fuse holder to put this in, rather than solder it on and put heat shrink over it? Is this a fuse? I think it is. Maybe if we can get this plastic off. There we go. Thank you. So if we can make out from where and to where it goes. That was really. It goes from there. That is one of the legs of it. And that might be the other one. Right there. So if right about, yes, I'm thinking that these are the 2 points that fuse did connect previously. And do we have continuity? We do not have continuity through there. So I blew the fuse. But we don't have continuity, but it's not 3.7 mega ohms. It might be making its way around here and getting back somehow. If that indeed is the legs of this, and if this indeed is a fuse in the first place. and there should be no resistance. But yeah, it certainly looks like a fuse inside that heat shrink in there. To get that out, I mean, how much do you want to muck about with this power supply? It's probably still completely fine, it's just that the fuse is blown. Well, I suppose you plug your soldering iron in then and try and desolder it. Yeah, I suppose. Bring you over here maybe a little bit. Yes, but even if you manage to so just shut up, I know. I just measured something with you only minutes ago. So there, that certainly looks like a fuse in heat shrink to me. And to make this, I don't even know what I do to make it a bit more serviceable. Desolder it there and pull it out and add something else and a fuse holder, something. The soldering iron is going to take a few minutes to heat up. Should maybe disconnect all this so we don't need to have that dangling about here. That's on the AC side, that fuse. So whatever happened, managed to get more, pull more from the AC than whatever that fuse is rated for. I think it is on the AC side. It certainly looks so. Yes, the separation is roughly there, and here's where the fuse is. Interesting. It could be, yeah, you'll get a lot easier access if you actually remove this from its housing. Yeah, but then I'll have to remove a lot more than these 4 screws. Then you have the fan, and you have the AC power connection and whatnot. Really. It might help. Just completely sure that there are no charge capacitors around here. Nope, not at all. In fact. Okay, the shortest one is for the LED on the back here, which is not of a whole lot of use, really. Get that out easily. Now if it's made to come out at all once it's in there. It doesn't appear so. No, and that is of course soldered onto the board. or did it pop out? It popped out. Lovely. Yes, that provide maybe more access. Yes, we can now peel off. Whilst waiting for the soldering iron to heat up, we can now peel off the heat shrink of the supposed fuse. Yes, what do we have here? Preferably we'd also leave enough of it intact to actually see what the rating is. But yes, this is a fuse. A ceramic fuse. Like that. There you go. Oh, wouldn't you know it? It actually has a... Aha! It's a good thing I didn't desolder this, because it actually has a fuse holder. I think it is in a fuse holder, maybe. That's what it looks like anyway. Or is that... I don't know how these things work. But to get an overcurrent all the way out here on the AC side, you have to short things out pretty badly on the DC side. Make it go like crazy before any other protection would kick in. Isn't it so? See if we can make out what it says. Maybe 6.3 amperes. 6.3 amperes? Really? .3 amperes? How did that happen? I can't explain with my previous hypothesis that connecting or providing a second return for the current from the battery through the second boost regulator, that in turn made it go a little bit crazy and adjust its current up to more than this thing is comfortable delivering on the DC side. Or will it? No, 6.3 amps at 230 volts. What the hell is what's that? So that's quite a bit. That's 1.5 kilowatts. For this thing to blow. How did I manage to do that? How the hell did I manage to do that? It seems as though it should be impossible. Almost. And I'm not sure that this is a fuse holder in that sense. It doesn't seem to want to come out of it anyway. Seems we're stuck. Okay, well at least I charged the battery for a little while and then I managed to blow a fuse. Here. And now you broke something. That definitely felt like something breaking. Yeah. The leg of this here fuse holder isn't very happy with me for the moment. No. It is maybe not the fuse holder, maybe it is just, there you go, that's your fuse, that's how you solder your fuse to a board. on soldering iron. Are you there yet? No, I'm pretty close. Pretty close. There you go. Here it is. Ugh, stupid idiot. What the hell are you thinking? I wasn't thinking. Really. Okay, is this thing actually broken or not? I got a weird reading of some mega ohms through it. Not through it, but when measuring this previously, yes. Yes, it is broken. That is what happened. This fuse popped. And I still can't quite explain why. Really. This really is for the AC input. It's basically the first thing that happens is that it goes through this fuse, or the last thing that happens depending on which way it is plugged in. And it is a 250 volt fuse, 6.3 amps. Well, there it is. It is sort of a fuse holder. That it is stuck in, but that is crimped onto it. It is not made to be user replaceable, put it that way. No, but not meant to be. That usually doesn't. It won't stop me from trying anyway. But even if I want to replace this, it's not the easiest thing to do. I still need something to mount there, and also slightly more expensive power supplies. They have this fuse here, and then the fuse holder, so it's very easy to get to and replace if you have an accident. That's the absolutely cheapest crap that HP has ever made in China. That's not. Okay, ladies and gentlemen, maybe that's it for now then from Dr. Plurings Battery Charging Laboratory. I managed to blow something this time, which isn't too bad. It's always something. Didn't quite blow up, but we did blow a fuse. But I don't quite fathom why it wouldn't work to do it this way, except that maybe connecting the negative first was a bad idea, as that indeed does provide a second return path for the circuit. So if I would have instead connected the positive up first, maybe this wouldn't have happened. But I would have needed to learn this lesson sooner or later in either case. So it's a good thing I learned it now, rather than with a much more expensive power supply. But then again, if I were using a more expensive power supply, maybe that would have a better protection circuitry that wouldn't even have blown the fuse for this, or where the fuse would have been accessible. You'll see a few interesting potentiometers here which have glue on them, so you're not supposed to be able to screw with them, or screw them. I'm guessing that those are your voltage regulation, so you could actually turn this up to a higher voltage if you just manage to disable the over voltage protection first. That should not be impossible to find the voltage protection thing in here. That is in here somewhere. I think I'm going to have to think about this for a bit, of what to do with this, and if the thing will still work, if with a new fuse. I'm not going unfused, I can tell you that much. But for experimentations, maybe try and get the fuse holder out here then again, how many of these here 250 volt 6-ish amperes fuses do I have? I don't think I have that many that are rated for high voltage. No, but that's it, ladies and gentlemen. Thank you so very much for watching. This didn't quite go according to plan, but we learned something. Cheerio!